guys, welcome. I'm going to go through questions 16 through 30 diagnostic test fix. Now keep in mind, there isn't multiple choice questions, so I'm going to treat each question like a free response question because that's all you guys are going to get. Okay, let's take a look. It says many urban zoos are looking at ways to effectively handle animal waste. One zoo has installed a facility that will transform the waste to electricity. To estimate how many pounds they would have to begin fueling, they discovered the total amount of waste was approximately normal. Okay. So it was approximately normal with the mean of. Okay, so what would I write out on my paper right now? I would jot down this, approximately normal. It says a mean of, right? A mean of and a standard deviation of, right? And it says the amount over 350 would generate enough electricity, approximate the proportion that they could expect. Okay, so notice I'm looking for the word sample and it's not there. So actually, this is actually the absolute mean. That's all the data they collected. And this is the standard deviation, right? Okay, and that doesn't happen very often, but this question was toward the beginning of class. If you notice, the questions 1 through 60 are somewhat chronological. Okay, so in the beginning, we took this data. What if I collected this data and it was approximately normal, and it says the average was, so remember we had this little flip chart. And so the standard deviation, one standard deviation to the left and the right would just be 348.5 plus 38.2, and this would be 348.5 minus 38.2. And remember, there's 6 flaps to the left. 1, 2, 3, 4, 5, 6. There are 3 to the left, 3 to the right. So this is 1 standard deviation to the left and right, 2 to the left and right, and 3 to the left and the right. Okay, and so where did I get all that? Just from this single word. Okay. So this is my mean, and this is my mean plus my standard deviation, and my mean minus my standard deviation. Okay, and so this is the foundation of everything we've been doing. And so what is it they're looking for me to do? They're saying, well, what if you had, what's the proportion of the days it would be over? Okay, so that's kind of asking the probability. And so that looks like something like this. So how we calculate that is we calculate the area under the curve, also known as our p-value. What is the area under the curve? 350 or greater. So it looks like a little less than half, right? Because 350 would just be a little bit above 345. Okay, so they're wanting to know the amount over 350. All right, so because of this, we can do in our calculator a normal CDF. And we have to give our lower bound, our upper bound, our mu, and our standard deviation. Right? So let's go ahead and find that in our calculator. It's been a while, so let's just do a quick refresher. Maybe you missed it because you just didn't have a calculator. So let's see. Stats, this is a distribution, right? There's this normal CDF, right? So my lower bound is 350. My upper bound is just a really big number, so I can put 1,000 or 10,000. My mean, I was told, is 348.5, and my standard deviation is 38.2. Okay. All right, so there's my answer, 0.284. So you're saying, what happened here? 0.284 is not one of my choices. So let's take a look. Oh wait, I didn't, that was my answer from previous. So somehow, I do this all the time, guys. Sometimes I type all that in and I don't hit return. So let's type that in again. Normal. Okay, so our lower bound is 350. Our upper bound's a really high number. Our mean, 348.5. Our standard deviation is 38.2. Okay, enter. Okay, beautiful. So that's actually, when you're doing a word problem, you're going to copy down what's on your calculator to show your work. So Normalcdf, 350, 1000, 348.5, 38.2, and that number equals 484. And so that's where I got my answer, 484. Okay? Awesome. Let's look at the next one. All right, this has to do with sampling. So we know that there's lots of variability in samples. That's just, no matter what the population is, if I take a sample, there's going to be a natural variability. So let's take a look. In stat class, we did a project where group 1 took a sample size of 2, group 2 took a sample size of 10, group 3 took a sample size of 2 as well, and group 4 took a sample size of 10. Okay, now each had their own way of taking a sample, and they each selected, and this is their data from 50 samples. So as we take a look, it says, the teacher ended up finding that the true mean height was 67.5. So I think that's pretty close to my height with shoes on. And that's why I tell a lot of students I'm the average height of people. And that's pretty accurate. So that's what they're saying here. So let's see which group had the least amount of bias and variability. You may have missed it because you're like, I don't know what bias means. So bias means how far away from your truth were you? So if we look here, here's the middle of each of these. It looks like these two choices had low bias. Okay. Because they were relatively close to the truth. All right. These seem to be off, like higher than the truth. Okay. Now the other question is, which one had low bias and low variability? Well, that's the spread outedness. So this one had low variability. And this one had low variability. So they asked us to pick which group had both low bias and low variability, and so that's how we got our answer, group 2. All right, question number 18. It says, every year AP Stats reading, they sell apparel. Based on this data, we know that 56% of teachers will buy it. If we take a random sample of 50 teachers and we select that apparel, what's the probability it'll be more than 60? Okay, beautiful, really cool question. So let's take a look. If I read through what they're asking me, they're essentially saying, kind of like the last question, I'd like to do Normalcdf and find the area under the curve, right? But I don't know if it's normal unless it follows my conditions, right? So I'm asking a yes or no question. So I got to think about large counts, right? So if I think about large counts here, if my proportion N was 50, right? And my P, or my P hat, this was a sample, right, was 0.56. So if I think about this, large count says N times P hat. So if I multiply those, I get, let me look at my notes. N times P hat, what do I get? All right, 28. Okay, so I'm going to be good. And N1 minus P hat, 50 times 0.44. So that's going to be 22 people, right? So that's good. So this question's actually spanning between when we tried to bridge from binomial CDF to Normalcdf. So these two values, as you start to complete the conditions, you will get values that are fairly close to the same. So I actually performed, because we are asking a yes or no question, are you going to order the t-shirts or not? And we do have the proportion that said, yes, I ordered apparel. Then this actually satisfies bits. But for ease of use, most of us use Normalcdf if we can. And it looks like we absolutely can. So let's go ahead and do that. In my sample size, if I took many samples, my sample mean should be N times B. So my sample mean should be N times B, right? And so I should get 28 out of the 50, right? That makes sense. That's what I should expect. So the only thing I need to do is what would be the standard deviation of this sample proportion. And that's when we have to get our formula out. That's the one thing that I think most people that miss this question were like, ooh, I felt like there was a piece missing. Well, my standard deviation should just be p hat, 1 minus p hat over n, and we have all that information. So that's the one thing that made this question a little sneaky. So let's take a look. P hat, right, is 0.56. 1 minus p hat, 0.44, divide by the number of teachers I talked to. Okay, beautiful. So what does this number come to? It ends up coming to 0.239. Now I have all the pieces to just do a regular old Normalcdf. So let's do that. Normcdf is lower bound, upper bound, mu, and standard deviation. Okay, so let's type that in. Normalcdf. We have our lower bound. So what would be the probability of doing more than 60%? So my lower bound would be 0.6, right? My upper bound can be a big number. My mu would be my proportion here. So that's 0.56, 0.56. And my standard deviation is 0.239. Did I get that right? No, that's not right. Sorry about that. I'm reading a number off of it. I'm like, that doesn't make sense. So there's too much there. Okay. The number I get is, 0.0702. Okay. All right, so let's take a look. I'm going to go to distribution again. Stat, distribute, Normalcdf, lower bound 0.6, upper bound a big number, mu 0.56, standard deviation. The one thing I felt like I was missing. Okay, they made me calculate that piece by hand. And there, I have my answer, 0.284, 0.284. All right, check out the next video for more questions.